I am a software engineer at one of the leading tech firms in Europe, but my journey started right here in Ogun State, Nigeria. As a teenager, I always wanted to be a medical doctor, but I found joy in coding during a 7-day digital bootcamp in 2016. Today, I work as a software engineer at one of the world's leading blockchain startups, and I've also worked with other engineering teams across 3 continents. My name is Shedrack. I earn well and thrive in a career that I love. It's safe to say I learned a skill and became a global talent. You can too.
All right. Okay. Good morning, good evening, good afternoon, everyone. And you're welcome to the very first class of software development. I'd like to hear from you guys if you can hear me before we kickstart. If you can hear me, please kindly signify in the chat section that you can hear me. All right, so I will give just a few seconds. And all right, great. You guys can hear me. All right, once again, welcome and good morning, good afternoon, good evening to every one of you. I'm glad to be here and I'm glad to have you all here as well. So you can also drop in the chat section where you're joining from, where you're listening or watching from, so that I get an idea of who my audience is. All right, great. Okay, so we'll go into the class proper now. My name is Beji Abimbola, and I'll be taking this class alongside Oluwabusola Adeleke and Chukwudi Emegboy. So we'll be joining you guys on this journey to becoming world-class software developers. And just a quick rundown of the course and what classes we'll be having and what days we'll be having those classes. So the classes we hold on Tuesdays and Wednesdays and Fridays, same time as today, which is 7 p.m. Nigerian time. Although we are having this class on a Monday being the first, but subsequently we'll be holding it on Tuesdays and Wednesdays and Fridays. So the next class in this week will be on Wednesday, and then the last class for this week will be for Friday. So our plan, myself with Oluwabusola and Chukwudi, is to actually help you guys through the journey to becoming software developers. Yes, we know that we have 3 months, and that might not really be sufficient to cover everything, but we are promising you guys that we will actually help you get to the very point where you won't be afraid to call yourself a software developer. So our plan is to actually take you through the fundamentals, and I will set you on a lifelong journey of learning to become a software developer. So I see people joining from Ogun State, people from Enugu, Lagos, Nigeria. Nice. From Delta, that's great. From Bagada, Lagos, from Arepo, Ogun State. I see Oluwatoyin Aluko from Ota, Ogun State. I see folks from Abia State, from Anambra. All right, so everyone, you're welcome. You're welcome once again, and welcome to software development class. So the curriculum that we'll be working with has actually been crafted in such a way to allow you to touch the major aspects needed for a beginner in software development. So we'll be looking at overview of software development and introduction to programming languages. Then we'll consider data structures and algorithms. We also look at software design, planning, and testing as well. And then we will end the course with full stack development. We'll look at a back-end development. We'll look at front-end development as well. And the purpose, again, is for you to have a good grounding in the required knowledge for a software developer. So what will be expected of you as a software developer is that, yeah, you understand data structures, you understand at least one programming language, and then you have a good idea of what software development process entails, right? So that you can function properly in a software team. All right, that's good. So, like I mentioned also again, it is a very short period of 3 months. And we all know that 3 months is not sufficient to make you a senior software developer, but it will give you enough grounding. So this is what I'm guaranteeing, that in the next 3 months, you have strong foundational understanding of software engineering. You'll possess practical skills in data structures and algorithms. You understand when to use what and when not to. And you gain real-world software design principles. So as a software engineer, what principles you use on a daily basis on the job, you will have good understanding of those as well. And then you gain an exposure to tools and dev team practices. So because you won't be working alone as a software developer, you'll be working in a team. So you need to understand what tools will be required, right? So the prerequisite for this class is that you have a laptop. We strongly recommend that you have a laptop or a desktop computer, but you can also code on your phone, just that it's not as convenient as actually using a laptop. And no prior knowledge of coding is required, but if you do have a prior knowledge, it is good. It's an addition. All right. Once again, welcome to software development class. And this is the very first class. We'll be looking at introduction to software development. And what we intend to cover in this class today is what software development is and why software development matters. I want to think that to an extent, you already figured out that, yes, learning software development matters, and that's why you enrolled in this class. But if peradventure you are still not certain why you should, and I'll quite understand, because nowadays the saying is that software development is dead. We have AI that can write software, but you'll gain a better understanding why it's still very productive to learn software development. So we'll look at why software development matters, And then we'll look at evolution of software development, where it started from and where we are right now. Then we look at types of software. We'll consider real life use cases of software. And then I will also open you up to what a software team looks like, right? So we'll consider what a software team looks like. And then how do you work in a software team? And lastly, we'll look at the software journey. How do you go from idea to actually having a software product? And at the tail end, I will walk us through a mini case study, much more like an activity for us to carry out as a class. So during this section, I will guide you on how to pick an idea for a software you would like to build. Like I mentioned, 3 months is the duration of the course. But at the end of that 3 months, we want you to be confident enough that you know sufficiently to actually start on the journey of software development. So I'll take a time to look at the chat in the chat box if there are any question or not. Someone is asking if this is not a general class. So this is not a general class. This class is for software development, and there are several other classes that are going on at the same time, depending on the one you enroll for. Let me also see if there are any more questions. Okay. So if you feel like you're not in the right class, you can go to the YouTube channel and see the right class for you. Okay, back to what we were talking about. So I did mention what we are going to learn in this class, but what are the learning objectives for this class? At the end of the class, I want you to have an understanding of what software development is and the importance in the real world. So, and also identifying various roles within a software development team. So yes, you have identified yourself as a software developer, but you are not alone in software developing. You are just playing a role. So it is good for you to also understand that there are other people playing different roles. So you will get to understand all of that by the end of this class. And then lastly is to describe how software products moved from concept to deployment, how you move from having an idea to actually deploying the software to your users. All right. Thanks again for joining. So what is software development? What is software development? Like I will usually say, people tend to want to think that software development is just about writing code. It is way beyond that. So it's beyond writing code. And you may have asked yourself the question, so what is the difference between a software developer, a coder, or a programmer, or a software engineer? And I would say that the difference actually lies in the process that each of them go through. For a programmer, they don't necessarily go through the process that a software engineer or a software developer will go through. And also the outcome from that process differs greatly for a programmer and a software developer. A programmer may just know how to program and may know how to automate some processes with Excel sheet, for instance, may also know how to extract data from a database, but that doesn't make them a software developer, right? Because they are just writing codes. And most of the time, those codes they're writing is for automation or just to help them in getting a job done. It's not like other people get to use that software. But for a software engineer, they go through the process of gathering requirements, doing design, then writing the code, testing it, and then deploying it, and then getting feedback and all of that. Anyway, we'll get to understand in deeper details the process once we get to that aspect of the software journey. All right, so to give you a definition, what really then is software development? Software development is the process of designing, building, testing and maintaining software applications. So you are designing the software and you are building the software and testing the software. And lastly, you are maintaining the software. All right, great. So I did mention that there is design involved in the process. There is building. Most of the time, the building phase requires you to write programs or requires you to code. Also, sometimes in the testing phase, you still are required to write some code for automated testing, and then you go through maintenance. And like I mentioned, what separates you from an ordinary programmer is that what you're writing is actually being used in the real world, and they are solving real world problems, and they are used to perform useful tasks for your users, or maybe another system is actually using what you have written to perform tasks. So it is a process comprising of activities and actions and tasks. For you as a software developer, say you're working in a team, you'll be given tasks. There will be activities for you to act on. There will be actions for you to take. And one of such activity might be you meeting with stakeholders. Stakeholders might be the product owner or the product manager, the CEO of the company you're working with, or the client success team, or even customer service, people in marketing, people in the sales team. Your job might require you to actually have meeting with those set of people. And why would you have to have meeting with those set of people? Because you're trying to understand the problem they are trying to solve. And with better understanding, it helps you in actually crafting a better software for them that addresses a daily challenge that they face. So the outcome is to have software delivered promptly and with sufficient quality. As a software developer, you are always faced with constraints for resources. Is it that the time is never enough, or money to support the project is not sufficient? All of these are the things that we actually have to work with as a software developer. You either are tight on deadline, right? And that has continued to be what underlines software development, to the point that some software development process fail in that the timeline is too tight and the people involved in the development are not able to work with that timeline to the point where they are able to bring out a software at the end of the day. But with proper planning, proper engineering, and with the right tools at your disposal, some of which we'll be showing you in the course of these 3 months, with those tools, you'll be guaranteed that you have you have better performance at producing good software. So as I mentioned, software are born out of business needs. If you're writing a software that doesn't meet business requirements or that does not satisfy a business need, that software is seen to have failed. For instance, you're working in a bank and your boss says that we want to build this software that will allow our customer be able to send money faster. But at the end of the day, you build the software and the customer sends money and it takes a week for the recipient to receive it. Such a software is not meeting business requirement, because the requirement is that the users be able to receive money on time, right? So also using the banking system as an example, if you look at your digital banking app of today, where you're able to just send money from your banking app and immediately someone receives it, that is a business need that has been met. We have a young generation and we have people who are on the go. They want to transact, they don't want to carry cash. That's a business requirement. How do you solve for that? You must ensure that the transaction does not fail. You must ensure that the transaction is instant. And those are the things that that gave birth to your digital platforms that you use today for sending money. So again, the software you are building must serve a business purpose. All right. So that's that about software development. Every software project is precipitated by some business need. We've talked about that. And you may also be asking yourself the question, yes, I have heard of software development. I've heard of being a programmer. So what about being a software engineer? So software engineering is an engineering discipline. And why that came to be is this. In the history of developing software, there were many methodologies that had been employed before now, and some of them led to a lot of failures. So it came to a point where there need to be a reduction in software failures. And some people came with the idea that they should see software development as an engineering process. And why so? Because many other projects, engineering projects that had been ongoing, had been succeeding, and they decided to learn from the process that engineers, like your civil engineer, the process they would go through that has been ensuring their success. So they adopted those methodologies from a typical traditional engineering process, and they brought that into software development, hence software engineering. So software engineering is an engineering discipline that is concerned with all aspects of software production, from the initial conception to operation and maintenance. So whenever you come across software engineering or being a software developer, just know that the process is what defines the two disciplines. The outcome, same. You are building software that is useful. You are building software that meets requirements. You are building software that people can rely on, that won't fail. Those are the things that are the outcomes of building software, or being a software engineer, or working in a software engineering team. So why does it matter that we build software? I'm very sure as of today, each and every one of you has interacted with at least one software. I mean, right now you're watching on YouTube. YouTube is a software. Yes, it's hosted on the web, but it is also a software. So software matters because it actually solves real world problems. It solves real world problems, and it drives innovation. There was such a time in this country that when you open a bank account, you can only withdraw money from the branch that you open that bank account with. So say you open a bank account in Lagos, you can't go to Ogun State and say you want to withdraw money from Ogun State. You have to go to your branch where you open the account. But with software development and technology, we are at a point where just anywhere in the world, it doesn't matter where you open your bank account, it doesn't matter how you open your bank account, you have access to your money all the time, and you can make transaction that is almost instant. That is innovation, actually. And today, software powers our daily lives. Like I mentioned, you are all watching on YouTube right now. Before now, there's no way you can reach thousands of people at the same time, or train thousands, hundreds of thousands of people at the same time. But technology has gotten us to the point where we are able to reach people from far and wide, right? And it also creates massive career opportunities. Now that you're learning this, now that you have opportunity to learn this, your career options expands. And lastly, it helps us to build the future. So I'll pause for a moment and see if there are any questions in the chat section, and if there are any ones that I can answer before we continue. Or if you have any question, you can just drop it and I will attend to it. All right. Someone mentioned if the slides for this class will be made available. Yes, there are resources bank for the class. and we'll make sure that the slides are made available to you. Okay, some people are asking for attendance list. We are just starting the class. At some point during the class, you will be attended to promptly. All right, so we just talked about why software development matters, and we went through the fact that it actually solves real world problem, and those are the things you want to be able to do as a software engineer. You want to solve real world problems, and it's not just about writing codes and all of that, but you really want to do something that matters to the world. So, well, we'll go to the next outline for this class, which is evolution of software development. Evolution of software development. All right, I'll look at the chat again to see if there are questions that I can take before I go into that. Yeah, so someone asked if we can call a software developer a software engineer. Yeah, to an extent. I mean, the discipline now overlaps each other that you can't really tell the difference. The processes each person goes through is the same now, that you can easily interchangeably call a software developer a software engineer. Okay, great. So, evolution of software development. And talking about evolution of software development, I will want to go through the different ages of computing and writing software. So, in the early days, people used the punch cards. I'm very sure most of us on the class today probably have not heard of that, but at some point, people punched cards to program a computer, as against the way we do it today. And then in the early 70s and 80s, computers entered homes. Then people now started having personal computers, which also changed how software was being created. Moving from punch card, now you actually have robust programming languages with which you can actually code with. Then in the 90s, there was the internet boom. So internet came along, or became much more popular around the 90s, leading to the birth of the World Wide Web, like we know it today, where you can go to through a website, through your browser, and visit a website and get information, or just as we are doing right now, you are on YouTube. Through a browser, you're able to watch me from wherever I am. So those are the evolution of software development, creating different opportunities as technology advances. And then we got into the mobile and cloud shift in the early 2000s to about 2010. And what that allowed us to do is, now you have mobile apps on your phone that you use every day. Mobile apps such as WhatsApp or Telegram or Instagram. And all of these apps were developed by software developers. And then in today's world, I mean, from today and into the future, starting from the 2020s through 2021, we now have the rise of AI-powered apps such as ChatGPT. You have no-code tools now. Now we work in remote teams because technology allows us to do that. And at this point, I want to talk a bit about well, I won't call it age-long debate now, but it's a debate that is coming up, that software development is no longer relevant, or programming is no longer relevant. Well, that's something that software engineering and software development have always thought about and envisaged, the discipline itself made accommodation for AI to come along the way. You remember when I said that we started coding with punch card, then it got to the point where we started using personal computers, which means people have computers in their home, which made it a lot easier for a single person to write a program and publish a program, or a small team to write a program and publish a program for other people to use. Yes, nowadays we have AI being able to write codes, but that gives a better opportunity, I would say. It gives a better opportunity. Now you can write software faster, you can write software smarter, and can have better collaboration. Imagine you have an idea and you don't have to type every bit of code that you need to get the idea to the market, but you can use AI to assist you in the process. That means that you get to deliver your product to the market faster than it would take. Now, I'll give you a good example. I was playing around with one of these AI IDs. It's called Cursor. I was playing around with that, and I saw how fast I was able to move in about a week. I mean, something that would take typically 3 months or 4 months to develop. In about a week to 2 weeks, I was able to actually develop something decent. And that's the age we have right now, where AI can take some of the extra work that you will have done before, can take it off your shoulder. And even the process of making sure that your software works right, that there are no errors in your software, AI can actually help you to a great deal in doing that. So for me, when asked the question of will AI take our job, I say AI is going to provide better opportunity. Now, a solo developer may not necessarily have to have a big team before they can bring their products to the market. Yes, maybe down the line, they will now have to hire a bigger team once the product is succeeding in the market. Nowadays, venture capitalists are actually funding solo developers, even developers that don't have strong technical backgrounds. Why? Because AI is actually enabling those people that would typically not have had the chance to build a software product. AI is helping them build now. So it is creating new opportunities. So for whoever is in this class and is wondering and concerned that it's too late for them to learn programming or become a software engineer because AI is doing that, I would say, no, it's not too late. And on the other side as well, this time is actually the best time to learn, because most of these tools that we are using today, well, as of today, to write code, some of them introduce errors that you need to have had experience in software development to even figure out. So it is actually a good time to learn, really. All right, so I'll go again to the chat section to see if there are any questions or concerns. Someone is asking, if you deploy and manage software for organization as a freelancer, can you be called a software engineer? Well, the role is quite specific since you mentioned deploy. So I want to see you more as a DevOps engineer, right? Someone is asking, how is YouTube a software? Going by the definition of a software is a program that runs on a computer. Right now, you're watching YouTube probably on your phone. Your phone is a computer. If you're watching it on a laptop, your laptop is a computer. Even if you're using YouTube music on your wristwatch, you're actually running it on a computer. So by the definition of what software is, which is program running on a computer, YouTube passes as a software. All right, I'll go through again to see if there are other questions that need my attention. So someone is saying, with AI, we won't have serious-minded software developers. Like I said, now is the time to actually hone your skills, because the time that I actually tested Cursor out, which is a tool for writing code with the help of AI, actually went through many iterations with it. And the same thing that has been the bane of AI, which is hallucination, still persists. Like, it will help you write code to a point, and it seems as if it's confused. And it will rewrite the code, introduce new errors that while you're trying to solve or debug an error, it brings in new error. But you as a software developer with good understanding of how software development is done, or you as a good programmer with a good understanding of how programming is done, you'll be able to spot those pitfalls and make corrections. And well, on the other side is people are saying, well, everybody is relying on AI to write their code today. A couple of years down the line, there will be a lot of security issues coming up because of codes written by AI that are not paying attention to security vulnerabilities and all. So again, it's not a time to say I'm not learning software development because AI has taken over. It's actually a good time to learn. All right, so that's that for evolution of software and how we got to where we are today. But then, what does it mean for you as a student today? You are entering a software development at a time when tools are more powerful. Now you are not punching cards to write programs, and knowledge is much more available and much more accessible. Now, with just a laptop and even with a phone, you can get something decent going on, right? So it's really a good time. And now you don't even have to have a degree to become a software developer. At some point, you have to be a graduate in either computer science or even have a master's degree before you can consider yourself to be a coder, right? But today, with just your laptop, with the right amount of curiosity and commitment, you are able to become a software developer. All right, so we'll go to the next outline, which is types of software. And mind you, I'm taking you through all of this because it will form a basis for subsequent classes that will come along the way, and also form a basis for your knowledge to understand where we started from in software evolution and where we are now. And talking about the types of software, you also get to understand the type of software that are there to build, or the types of software that are there to maintain. So we have system software, we have application software, embedded software. I will explain this with examples. We have web applications, we have mobile applications, and we have AI and ML. We have data software. And all of these that I mentioned, you can see them as some are generic products, while some are customized or bespoke software. What do I mean by generic product? So when you see something like Google Sheets, it's a generic product. It's not like it is customized for a company or for a singular person use. It's just a product that exists and you come there to use it. It is whatever the company behind the product offers that you get to use. So today, you're on YouTube. If YouTube decides to remove the like button like they did, you have no option but to continue to use YouTube like that. If YouTube decides to remove the subscribe button, then you have to continue using YouTube like that. So it's a generic product. But a customized bespoke software would be software produced to meet some certain requirements as required by a business or an individual, whatever the case may be. So any of this software can be broken down into these two categories, which is generic or customized. Anyway, so for a system software, we talk about OS or operating systems that runs on hardwares. So this software controls and manages computer hardware, and they provide a platform for other software. So like your phone that you're holding, it could be an Android, it could be using iOS, which is iPhone OS, right? It could also be a Windows computer that you are using or a Mac OS. All of these are operating systems, but they are the basis for you to run other software that you may have, such as you watching movie on VLC media. If you don't have like a Windows computer, you won't be able to install VLC. If you don't have a phone that is running Android or running iOS, you won't be able to install a VLC media. So a system software provides platform for other softwares to run. Then we have application software, which are designed to help user perform specific tasks. So you want to plan your year, you could use Excel sheet. You want to write a document, you want to write a presentation like the one I'm showing on the screen right now, you use PowerPoint. So those are software that perform specific tasks. Hence the name application software. You are applying them to a specific task. And then you have web applications. These are software also designed for specific tasks, but then you are able to access them via the web. So they run on a server somewhere and you access them via the browser. And you have mobile application. These are applications that runs on your mobile phone. And you have embedded software. So say, for instance, your microwave at home, you're able to set timer on it. The timer is because there is a software running in the background. That's why it knows when to start and when to stop. And your automated teller machines, they have embedded software in it that is able to tell the amount of money that is remaining in the machine and able to tell what denomination to give you. You have your smart TV. Now you can watch YouTube on smart TV. You can reduce volume, increase brightness. All of these are enabled by the software that are embedded in those machines. And then lastly, we have AI and ML software. We have ChatGPT that everyone knows. You have, for instance, you are shopping on Amazon. It gives you recommendation. Those are all powered by AI. So it learns your shopping habits and then gives you recommendations subsequently when you come back to shop. All right. So before we go to the next section, which is software in real life, I want to take a break again to look at our charts in the chat section. By the way, I'm not able to go through everyone's question, but as much as I can attend to, I will try to. So someone asked if they can learn software development in the university. Yes, I believe some university actually offer courses in software engineering. So if you enroll to their program, you should be able to learn all the tools and skills required to become a software developer. Okay, someone was complaining that the slide is not clear enough. Don't worry, you will have access to the slide. Okay. All right, great. So I'll give us all like 5 minutes to take a break. I was going to take the break after the next section, but let's give us 5 minutes. We've been on the call for 45 minutes now. I will give you time to use the restroom, drink water, and all. And when we come back, we'll talk about software in real life. All right.
I am a software engineer at one of the leading tech firms in Europe, but my journey started right here in Ogun State, Nigeria. As a teenager, I always wanted to be a medical doctor, but I found joy in coding during a 7-day digital bootcamp in 2016. Today, I work as a software engineer at one of the world's leading blockchain startups, and I've also worked with other engineering teams across 3 continents. My name is Shedrack. I earn well and thrive in a career that I love.
It's safe to say I learned a skill and became a global talent. You can too.
All right, guys, welcome back. This is the first class of software development. And before we left for the break, we had gone through some of the outlines that we had for the class. So we did go through what software development is and why software development matters, and then the evolution of software, types of software. And now we'll talk about software in real life. Software in real life. So I really consider it to be such an opportunity to be able to write code that actually impacts different aspects of life. For me, one of the experience I've had is working in finance and writing software that supports our financial industry, some of which are still being in use today. And then I've worked in my previous role in roles related to education and even communication, then business innovation at some point. But all of this is being given an opportunity to actually impact life. Because imagine writing software that helps in healthcare. That's literally using codes to save life. And the flip side is also true. If you as a software engineer makes a mistake in the software you're writing, and then it gets deployed for healthcare, that puts people's life at risk. And hence the discipline of software development and software engineering, and the rigors that we go through as a software developer in ensuring that what we are developing actually works the way they should work, right? I mean, I've heard of a scenario where an MRI device was developed, but because of the programming of the device, it was malfunctioning. The way an MRI should work is that you are able to scan, so it's passing out some waves of rays, but it begins to use very strong rays because of a programming error, and it led to people being exposed to rays that actually damage their cells. I mean, that's the impact of software in the real life. Hence the process that we actually go through as a software development team, and hence the seemingly hardness to breaking into software development. I mean, yes, you can write code, but the code should actually work. So we have software being used in finance. We have all the mobile apps that we use today in transferring money. You have software used in communication. WhatsApp is a good example of that. Zoom is a good example of that as well. You have software being used in entertainment. When you want to escape from the world, you can put on any of those software like Netflix, like Amazon Prime, and watch your favorite shows. But those are software in the real world, really. And all of these are powered by software engineers and software developers. And we are hoping that you also will get to the level where you're writing programs and developing software that is actually changing lives and impacting the future. So now let's talk about a software team. A software team. What a software team looks like. What you as a software developer will be doing in a software team. So a software team, a very basic software team would usually have a product manager, you have a designer, you have a front-end developer, a back-end developer, you have someone doing QA, which is quality assurance. They are performing tests on the software you've written. We have someone in charge of DevOps, so they are the one in charge of deploying the code that you've written so that everyone from around the world can have access to your software. Then in some teams, you have a tech writer, so they write about what has been built. I mean, depending on the type of product that is being built anyway, there are products that are targeted at other developers. So let's say you developed an API that other developers are using to build their own software, then you need a tech writer to write about that. But there are teams where one person wears a lot of cap. You have teams that you have a singular developer playing the role of a backend developer and a front-end developer, and sometimes doing DevOps. For such a developer, they call them full stack developer. Why full stack? Because they are working on the aspect that the user sees. They are working on the aspect that the users don't see, which is the backend. They are also working on deploying the app so that users can have access to it. So anyway, that's the basics for a software team. You have someone to manage them. So what does it really look like for a software team? So your product manager really is the one that defines what the software should do and why what you're building matters. So you can see such a person as a director. So we are using the analogy of a movie now. So you can see him as the director of the movie. The UI and UX designer, they design how the product looks and feels. So you can consider them to be like the costume artist or the set designer, while the front-end developer builds. So they build what the user see and interact with. So you can consider them to be the actor on the stage because they are actually people you see on stage. While the back-end developer builds the logic, they build the database, the infrastructure behind the scene. So you can see them as stage crew, those in the engine room. And then QA, DevOps, engineer, tech writer, you can see those ones as the editor, the proofreader, ensuring that the software you're building is of top quality. And you can see your DevOps engineers, the one managing logistics. All right. So what does a software journey looks like? I haven't gone through what a software team should look like. When we talk about software journey, we are referring to the process of taking an idea from just being an idea to getting to the point where that idea is now really a software that people use. Well, before we dive deep into that, I will look at the chat section and see what questions you have. So someone is asking if the video will be uploaded still. Yes, you will be able to access it on the LMS. Someone is asking if a software developer can develop games. Yes, you can develop games, but your specialty will be different from someone who is building software for the web. What tool you will work with will be different, but essentially the principles and the processes are about the same. Okay. All right. I can't see any other question. Okay, someone is asking for a differentiation between a full stack developer and a software developer. So for a full stack developer, like I mentioned, you are building front end, back end, and doing DevOps as the need arises. For a software developer, you probably are doing the same as well, but it's all depending on what company you're working for and what the job description is. For companies that I've worked with in the past, I was called an engineer, and all the engineering work that I did was limited to building front end and back end. I never had to worry about DevOps because we had a DevOps engineer. So I would say it's depending on the job description and the company that you're working with. For most standard company, they will just call you an engineer and not really say, oh, front-end engineer or back-end engineer. Why some other companies too will want to be specific and say they hired you for the role of back-end engineering. I mean, I've worked with a company where they hired me for back-end engineering, but I was still building UI, even though the UI I was building was not really customer facing. I was building UIs for internal tools that was used in the company. But then I was called a backend engineer, right? Okay, so I'll just give a general recap on who a software developer is or what opportunity you have being a software developer. I haven't learned all the tools that are required in actually producing software. There are many opportunities that are open to you. You can build a web app for other people, and you can build a web app, and that will serve as your own business. Say, for instance, you build an app that can predict tomorrow. I mean, for instance, and then you charge money for that. Like, okay, get prediction of what will happen tomorrow. Pay me $50 for it. I mean, you can build that and you may make money from that, right? Someone is asking if there's a difference between web development and software development. Web development is quite specific in that you are developing for the web. But as a software developer, you can also develop for the web, but it's just the naming and the specificity of the platform where your software is being used. So for a software developer, you can be developing for desktop, and you can be developing for the web, you can be developing for mobile. But again, at the end of the day, all the knowledge that you will require, all the basics and fundamentals that you require to succeed in any of those roles are what you learn in such a course as this for software development. Okay. All right, so let's get back into the class. And now we'll talk about software journey, the software journey. So, like I mentioned, you as a software developer, most of the times, or a bigger percentage of the time, you are not working alone. You're working with other people in the team. And you as a software developer are not just a programmer. You're working with a business constraint. So you are working to meet a business need. And most of this business need will come through the process that we call discovery. So it is the initial step in developing an app from an idea. So in this phase, you're trying to identify the problem. You are trying to understand what the users need, and you are defining the business goal. So in identifying the problem, so you are trying to figure out if what you are building really matters and what exactly it is that you are building. So let's cite an example. For instance, let's use a very simple example. You are trying to build a calendar app. So your calendar app is able to book a calendar entry. Say, okay, tomorrow morning by 8:30 a.m., I want to have my breakfast, right? So what problem exactly are you trying to solve? Your calendar app is trying to solve a problem of being able to remind the users what they planned to do. So the problem is being able to help people remember what they have committed to. So that's the major problem that your app is solving, right? So identifying that problem is part of the discovery that you're going through. So if you want to commercialize the product, now you also have to identify the business opportunity around it, which is also part of discovery. But for you as a software developer, you may not really have to go through this phase by yourself. But there are other instances where you have to wear the cap of someone doing research, doing user research to better understand how to build for the users that you are targeting, right? So you are defining the business goals as well, and also trying to assess what your user need. And a mistake that we often fall into sometimes is that we identify a problem, but we don't really go ahead to understand if that problem is what every other person is having. So you feel like it's a problem, but not other people. Other people may not really have that problem. But the process of discovery helps you in figuring those out, in really knowing, okay, is it just two people that have this problem? Is this problem a global problem? Is this problem age specific, or is this problem a regional problem? For instance, here in Nigeria, we have power outages. Some might say, oh, they want to build an app that will be able to tell you when power is going to go out. And for you, you say you want to build that app and also sell it in the US. They don't have such a problem in the US where there's frequent power outages. So such a product won't sell in the US, right? So in the discovery phase, you are also trying to understand the region you are building for and the region to which those problems are specific to. So all of this happens in the discovery phase. Then we now go to the next phase, which is the design phase. And what you're doing in the design phase, a lot of things happens in the design phase. A lot of principles, a lot of design principles to consider in this phase. And what is the purpose of this? So having this defined what the problem is that you're trying to solve, there's also a need for you to understand how users will use your product, and hence the design phase. So you're designing for good user experience. And what user experience means is that when a user comes to the app, it could be on a website, it could be on a mobile phone. Once a user is using the app, they are having a good experience of the app. Not that they come to the app and let's use our app example that we are building for Nigeria to tell when NEPA will take light, right? So a user comes to your app and then you say, oh, there will be power outage in the evening by 9 o'clock. And it comes to 9 o'clock, there's no power outage. Very soon, nobody will trust your app. Or you say, oh, there will be power outage, but you don't specify the time. For that, the app is really not useful, right? Okay, so in the software journey, the design phase actually ensures that the user need is being met. The things that a user wants to see in the app are actually outlined properly, and then that you're following design principles in actually doing those design. But then I will leave this phase for those who are focusing on product design. But for you as a software developer, you also need to have a basic understanding of what design should be like, because you'll be interpreting what a designer has designed into working product. All right, so I'll give us another 5 minutes so that we can sign the attendance register. So I'll give us 5 minutes. So while we are doing that, if you have questions, you can also drop them. All right, you're welcome back. I hope you all were able to sign the attendance register. Okay, so we had a couple of questions while we were signing the attendance register. I would like to take some of them. So someone was asking what programming languages we'll be learning for the class. So we'll unveil that once we get to I think by next week we'll introduce the programming languages for the class. But yeah, be rest assured that it's a simple programming language that you can easily catch on, and it's a popular one too. Someone asked, in a situation whereby front-end and back-end developers are working collaboratively on a project, does the back-end team need to wait for the front-end team to finish its part of the project before? Yeah, so essentially you're asking, would there be a need for you to wait and all? So it's depending on your team structure. For a back-end engineer, you can actually go ahead and develop. But in order for your front-end engineers not to be waiting, they also can sort of mock the data that a back-end engineer will typically provide them. So the back-end engineer is building the API, essentially providing data from the back-end that the front-end will use. So you on your front-end, again, depending on how your team is set up, you on the front-end, you can actually use like fake data. Even your backend people can also provide you with like fake data whilst they are still building the functionality of the API. So, but in teams that I've worked in before, like in my previous role, that's why they actually wanted a full stack developer. So there won't be such a need for front end waiting for back end or back end waiting for front end. But there are other ways to mitigate such a challenge. It's all depending on how your team is composed. All right. Someone asked, is it possible to be a solo developer before getting a job? Yes, it is possible. You can freelance. So you can go on any of these gigs website. There's such as Fiverr and the likes, where people just want to do some few tasks. So you can be a solo developer before you get a job. You can actually decide to go on the route of an indie developer. So an indie developer is an individual developer. And you can decide to build a business around that and not really be employed in a job. But it's all depending on you and how much effort you put into learning, and I guess business acumen that you also have, amongst many other things. So yes, you can be a solo developer. I'm still scanning through to see if there are any other question. For those of us asking for the link is in the chat section now. You can try and scroll towards the end of the chat. You'll see the link in the chat. Someone is asking, is it necessary that software dev have to program alone without others? I don't fully get what that means, but I'm guessing the person is asking, is it necessary for you to write codes? Well, in this era, there are no code tools, but like Chukudi, one of the facilitators, advised, it is good for you to understand how this thing works underneath, so that you are never left in a place where you have to fix something, but you don't understand how it works. But yes, there are no code tools where you can just drag and drop, and then you build working software. But again, we will advise that you actually learn how to program. Someone is asking, can one be efficient as a full stack developer? Why not focus on one instead of divided attention. Well, I think this also is depending on the individual. So, say for instance, myself, I started my career as a graphics designer. I mean, I picked an early interest in graphics design as far back as when I was in secondary school. So I've always had eyes for good design. But then I studied computer science in university. So by that fact, I was exposed to software engineering. So coming out of school and having a background in graphics design, and still to till today, still having that desire to build front end apps, and still on one other end, having the desire to write back end code. I mean, I comfortably combine the two today, but you're right. Yes, I have preference for one than the other, and I have a leaning towards back end than than front end. But I combine the two gracefully today. So it doesn't stop you, neither does it take away from you. It's all depending on your desire. Some people go fully into backend, and that is the only thing they do, right? And they are really good at it. Why some people focus on front end? Why some people just want to be able to do everything? It's depending on their motivation, it's depending on their leanings, it's depending on their interest. For some people, they want to be able to build software that everyone will use someday. So they feel like, oh, they need to understand every aspect of building a software. Some go as far as learning project management, learning product management, learning UI UX. I mean, for instance, for me, as part of my training, I learned the basics of user interface and user experience, and I, to a good extent, can use tools like Figma, can use tools like Adobe XD. Yeah, I learned it because I felt it was necessary for my career. So to answer simply, it's depending on your desire, it's depending on your career trajectory. If your career is leaning towards the point where you have to learn front end development at some point, you shouldn't shy away from it. I mean, once you like it or have any little interest in it, I think you should pursue it as well. All right. I think that's that about the questions that I'll be able to take for now. So someone asked if a UI UX designer can also be called a front-end developer. A UI UX designer is just a designer, not a front-end developer, because really at the end of the day, they are not building anything. The most you can get from a UI UX designer is a prototype, and you can deploy a prototype for your users to use. All right. Yes. So let us get back to the class. So we were talking about software journey before we took the break to sign the attendance register. We talked about the discovery phase of the software journey, where you actually figure out the problem you're trying to solve. You figure out the idea, and you define a business goal, and also assess what your users need. Essentially, you're not just building for building's sake. You are building to solve a problem. You are building to meet people's needs. And for some, you're building to actually make profit. So that is the phase where you figure out all of those details. Then when you go to design phase, which was what we talked about before we went on the break, here you're actually designing for a good user experience. Having figured out what your users need, now you are putting together a design to meet those needs. And again, I would like to point out that the design that we are talking about here is not just UI UX alone. In this design phase, for some teams, they actually go into architectural designs. So they decide on where to deploy the product, where to DevOps process that they will need to go through, or what database of choice, and all of these are in the design phase. All right, so we go to the next phase of the software journey, which is develop. For most of us here, you'll probably be most interested in this part because this is where it gets to code. But again, just to reiterate, our responsibility as software developer goes beyond just coding. There are many other aspects to what makes you a software developer, right? So here is where we have our backend and our front-end development. So backend development manages the underlying system logic. For instance, how you authenticate users. For instance, you send money. So how do you handle deduction from one account, and how do you credit the other account? What database process you have to go through in order to ensure that that is safely done. Then for your front-end developers, they develop what you or your users actually get to see on the product. So this phase of development, you go through coding, you go through DevOps and the likes, and you go through some form of testing. So all of this also is depending on the kind of process that you adopt. Although I won't talk about those processes now. I'll wait for the second class where we talk about software life cycle, software development life cycle. And then the subsequent one where we now talk about agile development and get into the details. But again, how you go through this journey can be dictated by the methodology that your team is adopting. So if your team is an agile team, the process might vary a little bit. So we now go to the next one, which is the testing phase. So having built your software now, I mentioned earlier the purpose of writing code or building a software is to meet a business requirement. Part of the things that is expected of your software is that as the user is using it, it's actually meeting their needs, that the software works right, that the software is reliable. And how do you test for all of this? You test by going through testing. You do QAs, right? So you have QA engineers that find bugs in the software you have built. And what are bugs? Some people test for user-facing bugs. So let's say you build a web app, for instance. Are you clicking a button and it is not clicking? That is a bug. What do we mean by bug? Like if you expect something to work in a way but it's not working as it should, then there is a bug in it. Well, maybe I should give us an history of how the term bug came by. When I mentioned the software evolution that happened and how we got to where we are today, I said we started with writing programs on punch cards, and that was where bugs actually started, because there was such a time that a team wrote a program and it wasn't performing as it should, and they figured out what the issue was. A bug had died in between one of the punch card, thereby stopping the program from actually working like it should. So that term bugs stuck with software engineers and software developers till today. So when you find a bug, it means that something is not working as it should. So in the testing phase, you are identifying bugs. What is not working as it should. You are reporting the bugs. So you are documenting the bugs and you are creating issues. Part of the software process will mention tools for managing bug reportings. Then you probably create a ticket for your software developers to fix the bugs, and then you retest the software again. So this continues in the life of the software. Yes, I did mention that in the life of the software, which means that a software do have a start and they do have a end, and their end is when they are no longer needed, or they are no longer serving business needs, or no longer useful. So in their lifetime, there will be a continuous need for testing as long as it is being used. There will be bugs that will be reported. There will be bugs to be caught. And we go through that cycle of identifying, reporting, fixing, and then retesting. Then we go to the next one, which is deploying your software. And we'll talk about this also extensively in one of our classes that focuses on deployment, at which point I'm hoping that all of us in this class, we have something to actually deploy. So deploying the software is making the software available for your users to use. But prior to deploying, someone did mention earlier or asked the question about how a front-end developer should relate with a back-end developer. So that relationship matters in how you deploy your product. So let's say your back-end code exists as a separate project and your front-end code exists as a separate project. Imagine that you deploy your front-end code, an updated version of it, and you did not deploy a backend that is also updated. Now you have a button on the front end that once you click should do something in the backend, but the backend is not up to date, right? So that will create a bug. So in the deployment phase, you have to determine how you handle your pipeline. So there's such a thing called pipeline, which is what you can see it as a pipe through which your codes go through till the point where they actually get delivered into the hands of your users. So you deploy products, maintain stability, you are collaborating with the different teams, you are integrating process at this point. For some team, they are part of their deployment plan is that they perform automated testing. So they have a set threshold that this amount of tests must pass before this software update is delivered to the customer, before this software gets into the hand of the customer. So all of this happens in the phase of deployment. And then lastly, we have user feedback. Like I said earlier, depending on how your team is set up, this may work slightly different. So for some team, they work iteratively. And what do I mean by that? The product they are building is iterative in that they are getting requirements from their users and they are building features. Then they go back again and get newer requirements and they are building features. So let's take the quite popular WhatsApp, for instance, as a case study. I wouldn't know how many of us knew when it started, but I remember when I started using WhatsApp, I think it was around 2012 or 2013, which is about some 12 years ago. The features they have today, they didn't have then. And it's through this iterative process of getting user feedback, gathering requirements, developing and deploying that WhatsApp got to this point that it is. For some people, they argue that, oh, Telegram is what WhatsApp is copying. Maybe it's true, maybe it's not. But I also know that WhatsApp actually gets feedback from its users. There are times when you make WhatsApp call, at the end of the call, they will ask you to rate the call. That's a form of user feedback. There are other software that goes a little bit more aggressive in that in every process of the way, as you're using the software, they're actually watching what you're doing, although you may not see exactly that they are doing that, but they are monitoring how you are using their software, and that serves as a way to get user feedback. While they are monitoring, yes, they won't look at uh, personal identifiable data like your emails or your password. They may not look at that, but they are looking at how you're using their software and why is that necessary, so that they know how better to improve the software to better meet your need. So this phase of user feedback is actually important for a software journey. If you're not getting user feedback, there's high chance that you are losing your users. So let's say, for instance, now, I mean, a lot of us have been providing feedback. Earlier in the call, someone was saying that, oh, my audio was echoing, but that's just a single feedback from one user. But imagine 20 more people say that. That means I have to adjust it. But if I don't adjust my audio and just ignore the feedback, that means more people will drop from the call. They'll be like, oh, they can't hear, they can't follow the class. That also happens for software. If you choose to ignore your user feedback, you start losing customers. I mean, there are banks today in Nigeria, or there are companies here in Nigeria, where I'm from, that lose customers because they just ignore their customers' feedback. I mean, we encounter this thing every day, where you walk into the bank and you lay a complaint and they tell you they can't do anything in until another 7 days. Whereas another bank somewhere will say, oh, yeah, we can help you fix this. And in 30 minutes, they have fixed that. So that user feedback is actually key in helping your software evolve and sustaining your software and providing good longevity for your software. So I will take a pause here and look at what questions we are asking in the chat section and see how much of that I can answer before we proceed again. Someone is asking, how can I build a web app? Yeah, your question will be answered in this class. Just make sure you continue with the class, and at some point you'll get your answer. Someone asked for a differentiation between front end and back end. I think I already spoke to that. Someone is asking, what's the difference between software developer and software engineer? I also already spoke to that. Oh, someone said, okay, someone was asking what is UI UX. So the full meaning of UI is user interface, user interface, and then UX is user experience. So user interface is what you see, what you interact with, and then user experience is the experience you get as you're using the software. Is it a good experience? Is it a terrible experience? All of that is defined under user experience. Oh, nice. Someone actually already gave the full meaning of UI UX. Nice. Okay, I'm still hunting for more questions before we go back to the class. Someone made a joke. Bugs are as old as that. Those annoying errors. Yeah. And you have to build a tough skin for debugging, because you will encounter a lot of bugs in your code. But as time goes on, you have a good grasp of how to actually debug errors in your code. And as part of this class also, we will be teaching debugging your code and the tools that you can actually use in debugging code. So sit tight. In subsequent classes, you will get to see that. All right, so I'll just scroll to the end and see if there are newer questions. Someone was asking if Play Store pays you for every app download of your app. Well, not directly. So your app can be monetized either by allowing advertisement on your app. So the advertising company that you permit to advertise on your app pays you. If it is Google, they pay you. If it's some other companies, they pay you. And you can also monetize your app through other means as well. But that's beyond the scope of this course. But I saw that question. I thought I could speak to it. Yeah, another question here is, can you be an all-round engineer? Well, like I mentioned in the beginning of the class, this career path is a lifelong journey of learning. I know of someone who has been writing code for close to 40 years. They are in their late 50s, I think, and they've been writing code for that long, and they're still learning. So it's a lifelong journey. So if I do understand the question correctly, can you be a front-end engineer? Can you be a back-end engineer at the same time? Is that what the question is? And I think, yes, you can. All right. So thank you for all your questions. Someone is asking, what happens during a software update? Yeah, a lot of things happen. Say, for instance, you are using WhatsApp and WhatsApp is asking you to update your software. By the time you update it, you see that new features actually are now available to you. So during a software update, you're essentially downloading a newer version of the software to your device. It could be your phone, it could be your laptop. So that is what happens during a software update. All right. So again, the slides for this class will be made available once we figure out a way to share it across with everyone. It will be made available. It's free. Nobody's charging you for it, so definitely it will be made available to you all. So let's get on to the last part of this class. So what I want you to do for this part is pick an app that you might want to build, that you particularly have an interest in. So I'm going to use a to-do app for a case study, but yours don't have to be a to-do app. It can be just about anything. It could be a birthday reminder app, and what the app does is send a reminder to your friends and family when it's their birthday, or send you a reminder that, oh, this person is celebrating their anniversary today. I mean, it could just be about anything. And you can also use the example I gave earlier, which is you want to build an app that predicts the future. I mean, if you do have a domain knowledge in that, you can do that. And you can also pick an app that tells when NEPA is going to cease power. You can do that as well. But I just want all of us to have an app in mind, and then we go through the process that we just talked about, which is discovery, and then design and develop. So the question to ask yourself is, this app that I've chosen, what particular problem is it solving? And the reason for this exercise is to actually help you see software development beyond just the coding aspect of it, right? So ask yourself, what problem does it solve really? So for me, a to-do app helps me solve a problem in that I can highlight all the things that I want to do tomorrow. I can put them down today, and once I start my day tomorrow, I can start crossing them out. So it helps me with productivity. So it actually solves a problem. And then does he have a business opportunity? Yes, it might have a business opportunity. I can decide to put my app on the App Store, like someone was suggesting earlier, that can they make money off App Store as their app is being downloaded. So I can put my app on the App Store. So yeah, there's a business opportunity for such an app. And then I want you to go through the phase of design. So how should the app look like? What should the app look like that will make it really useful? So for your app that predicts the future, I think if I am to design such an app, I'll make it in such a way that I will be able to speak to the app, like launch the app, press a microphone button and talk. And then I will get a response that will say, tomorrow is well, tomorrow is all right, right? So that could be a design for such an app. For your app that tells when there will be power outage, it could be that you want to put a date or put a period, let's say from now till the next 3 months, tell me when there will be power outages. So these are design choices that you make as you're building an app. And then you want to make a good user experience. Like when your users come to use the app, you want them to have a good experience using it. So you can decide to improve it. So say for your to-do app, you can say, oh, I want a user to be able to just talk about what they want to do tomorrow. And then my app will figure out what task they should carry out. So that sort of improves your user's experience, right? Then we go through the journey of developing. Now you make a choice on, oh, what programming language do I want to develop with? What backend should I have? Yes, we'll get to the point where we'll make those choices, or we'll talk about those choices and you have a better understanding of how to make those choices. But for now, maybe focus on discovery and focus on design. And the reason, again, for this exercise is you'll be working in a team of people, and it is important for you to actually be able to understand why some choices were made during the process of discovery. Some of them may not make sense to you. Some of them you will feel like, oh, they're just making life difficult for you. Why can't they do it that way? No, most of this decision are backed by data. So when you are given a task to work on as a software developer, just know that someone somewhere has done a research that led to the task that you're working on. I mean, most of the time, someone somewhere did a research and they went through a discovery phase before they landed on the task that you're working on. And as it comes to design as well, when a UI UX person works on a design, they are bringing in their expertise of understanding how users think and how users interact with their computers or their phones. And all of those experiences informs their decision on design choices. And as you begin to understand that, it helps you as a software developer to appreciate what every person in the team is actually bringing to the table as you join your software development team. So you too should go through that phase, learn to a minimal extent how to design a basic app. You don't have to be a guru at it, but just to appreciate the process that happens when a designer gives you a design file. All right, so that's that for our class today. And I'm hoping that we all got something out of the class. So what is next? The next class we'll be talking about software development lifecycle, and one of the other facilitators will be the one to take us on this class. And like I introduced when I started, my name is Deji Abimbola, and the other facilitators, we have Oluwabusola Adeleke and we have Chukwudi Emegboe. So Wednesday, you should be expecting to see Oluwabusola Adeleke. She will be taking you through software development life cycle. I know you all are looking forward to when you start programming, but again, being a software developer goes beyond writing code. All right, so for the few minutes that we have left, I'll be looking through our questions again to see some of which I can answer before we call it a night. All right, so I see people dropping the apps that they have in mind to build. Someone says they will build a stress detector app. That's nice. That's really nice. Someone says they want to build an escalation app to escalate issue to vendor. That's really thoughtful. I mean, now that you have a lot of online vendors, it will be useful for you to have a means of escalating issues. Maybe even have a way of rating vendors. I mean, if you have a vendor that has like five-star rating, you know that, oh, if you deal with such a vendor, you are going to get good services from them. Okay. Someone is asking if they can have the curriculum. Again, once we figure out a good way to share the resources that we have, we will share them with you. All right. Someone says they want to build a fitness app. Yeah, but mind you, there are a lot of fitness app out there as well. So the question is, are you building it for the fun of it, or you're building it because you feel like it's going to be useful for those who are into fitness? Okay, someone asked again, what happens during the software updates? Okay, I think it's the same person, so I've already answered that question. Someone says they want to build a learning system application. That's nice. And a social network. That's great. Yeah, we may say that we already have Facebook, we already have Instagram. Why should you build a social network again? I mean, yeah, Facebook right now has not covered everyone on earth. So your social network can also thrive. And your social network can also have like different selling points that Facebook or TikTok is not offering. So yeah, go for it. I want to build an app that can connect Christian singles for dating and relationship. That's nice. All right. Someone says they want to build health app that connect a patient and the healthcare professional. That's good as well. Although there are a lot of apps doing that, you might want to do your research to see what they are doing right and what they are doing wrong that you can improve on. Someone says they want to build an app, but the challenge is uploading into the Play Store. I don't think that's a challenge. There are processes to submitting your application to the Play Store or the App Store. How can I have a team? Yeah, once you identify what you want to build, the business you want to do, you can figure out how to hire your team. So now you are going to have to be able to decide who you want to put on your team. Is it a software engineer, a designer, or are you a software engineer yourself and you just need someone who will be in charge of the business, and so on and so forth. An app that links potential buyers of foodstuff, cosmetics, clothing, and other necessary items directly to the producer. Yeah, there are businesses built around that, and businesses that are currently really doing great in Nigeria here. So it's a good business opportunity as well. Yeah, so all of these are really great ideas that you guys are coming up with. But again, for the purpose of this class, we have to go through the process of designing or the process of discovery and designing and then developing. So someone is asking, can a site created by just front-end developer be deployed without a back-end developer? and allow users to use it properly? Yes. So it's now depending on what function you want your users to have on that website. There are apps that really do not connect to a database somewhere. There are apps that really do not connect to an API. I mean, there's this app for framing your picture that I think some of us may have used before. So you have a program, they customize a website for you to go and upload your picture, and then you download your picture with the program design. That app does not have a backend. Every part of it is just a front end, really. So you can have just a front end app that really doesn't talk to a backend, and it will still be functional. Okay, I'm still looking through our question. I see some questions are asked over and over again. Oh, nice. There's a lot of questions that I can't keep up with, but I'm just trying to see if there are questions that we can all benefit from. Someone says they want to build. Can they build an app that teaches all subjects in your native language? Yeah, it is possible. But it's going to take a lot of work because right now, so if you say you want to teach in your language, so I'm guessing the app will provide audio teaching. And right now, I don't think we have a lot of Nigerian languages that are available for such. But definitely you can, depending on how you go about building it. You can decide to build an LMS and have multiple uploads of different languages, or you can decide to train or build your own language libraries as well to deliver those courses. Someone is asking for recommendation for additional studies. Yes, we actually have a bank of resources that we allow you study further. Like I said, 3 months is not sufficient for you to cover every aspect of software engineering. So we'll be providing that. We'll be providing all of that for you to help assist you and point you in the right direction. All right, so I think that's that about for the questions that we have in the chat section. So great having you guys around, and we'll see you in the next class. Do have a wonderful night for those who are in Nigeria, and do have a wonderful day ahead for those who are just starting their day. See you guys in the next class.
I am a software engineer at one of the leading tech firms in Europe, but my journey started right here in Ogun State, Nigeria. As a teenager, I always wanted to be a medical doctor, but I found joy in coding during a 7-day digital bootcamp in 2016. Today, I work as a software engineer at one of the world's leading blockchain startups, and I've also worked with other engineering teams across 3 continents. My name is Shedrack. I earn well and thrive in a career that I love.
It's safe to say I learned this skill and became a global talent. You can too.
I am a software engineer at one of the leading tech firms in Europe, but my journey started right here in Ogun State, Nigeria. As a teenager, I always wanted to be a medical doctor, but I found joy in coding during a 7-day digital bootcamp in 2016. Today, I work as a software engineer at one of the world's leading blockchain startups, and I've also worked with other engineering teams across 3 continents. My name is Shedrack. I earn well and thrive in a career that I love.
It's safe to say I learned this skill and became a global talent. You can too.